This week we are going to talk about the nitty gritty of the layers of the earth. So get ready to dig deep into the layers of the earth. So, what you guys already know, here's our earth, and you know at this point that the earth has 4 layers. We've already talked a little bit about the crust. I'm going to mention it one more time or a couple more times here because it's really important that you know this so that you can understand all the earth's processes. So here was continental crust made out of granite mostly, oceanic crust is basalt, and then this second layer is the mantle. I've only shown you a small section here of the mantle because it's really important. This part right here, the lithosphere, is malleable, it's ductile, it's viscoelastic, it's plastic. It means that it's bendable. So when you put the crust on top of this bendable rock layer here, we call that the lithosphere. So we're going to take a look at it one more time. Here's our granitic layer of continental crust. There's the basalt. And then we have this dividing line. It's called the Moho discontinuity, and named after a scientist. And there is a vast difference between this solid rock and this very, very different kind of material in the mantle. It's still rock, but it's movable, not liquid. So please make sure that you check out the video for the Oobleck Lab. It really helps explain that quite a bit. All right, so let's take a look at the overall picture. We've talked about this part quite a bit. We're going to skip down to the outer and inner core. Once again, things are much different. So we're going to talk about this part right here. This is the outer core, and it actually is liquid. This is the true liquid, and it's liquid metal of iron and nickel. So as the earth was cooling, those heavier elements like iron and nickel migrated down to this section. It is incredibly hot, not enough pressure to make it solid like the inner core. But that outer core is this liquid, and the liquid is on the move. It is it's flowing up and down, and it's going to create a magnetic field. Now, as the metal moves around, this magnetic field, just like you would have here, you're used to looking at a bar magnet, and if we put all these iron shavings, you would see this magnetic field. That's what's happening around the earth, and this is the usual picture that we see. It's coming out of the South Pole and coming back in at the North Pole. It's not really quite what it looks like. It looks a little bit something more like this. Here's our Earth. That's just supposed to be a picture of the liquid core, and it's creating this shield, this magnetic shield around our planet. Thank goodness, because this magnetic field right here is going to protect us from the sun. Now, how do we know about all of this stuff? Well, there is a series of satellites. These are so cool. They're called the Swarm because there's multiples of them. And they are the European Space Agency. And what they do is they scan the Earth, and they are specifically looking for the magnetic field. And you can see here the magnetic field is very variable. Is really, really cool. So we don't have time to get into that right now. Just if you ever wanted to look up the Swarm, super awesome stuff. Okay, here's some more data from the Swarm. So what we have here is, here's what we usually see. Here's our magnetic field, and we're going to see that that magnetic field is changing. It's not like that first drawing, something super simple. And what this is helping us track is the movement of the magnetic North Pole. So here's the geographic North Pole. That's where our Earth is spinning on its axis. The magnetic North Pole is, if you remember that other chart, where that magnetic field is coming back in. So take a look. In 1900, it was here. It is on the move to Siberia, and it is actually moving in it quite quickly recently. So in the past, our poles have flipped north from south, and it will happen again, probably not within our lifetime, so we don't have to worry too much about it. So why do we even have this magnetic field? Well, we know why, the liquid outer core, but what does it do for us? And this is what it's protecting us from, is the solar wind. Every once in a while, the sun will have one of these solar flares. Well, it will eject a huge amount of um, charged particles, and they will go across the solar system, and they would hit the Earth, and they would wipe away our ozone layer and quite a bit of our atmosphere. But the magnetic field prevents that. And here's a different picture of that. Here's the sun, not to scale, solar flare, and here comes those particles, and they get deflected. Now, sometimes the solar flare is so strong, it will actually enter in sort of the weak spots, the North and the South Pole. And that's where those charged particles hit our atmosphere, and we get charged particles in our atmosphere, mostly oxygen and nitrogen, and they excite those molecules, and they make these beautiful northern lights. Sometimes you'll hear them as northern lights, southern lights, or the aurora borealis. Okay, so let's dig even deeper. Now the heat is incredibly intense, and we have more pressure, and so we have a solid inner core. So that is our last layer of the Earth, is that solid iron and nickel core. So let's real quick recap. Here's our beautiful Earth. There's our little moon up there. And we've gone through all the layers. So please do take a look at the video on the Oobleck Lab to help you understand that outer core. And thank you so much for watching.